Today our discussion topic is real numbers of class 10 CBSE and we will discuss about exercise 1.3. Before going to exercise 1.3, I want to discuss about one thing which we have written. I have written already. Let P be a prime number, and if P divides A square, then P divides A, where A is any positive integer. So to understand it better, I want to take an example for you. You can take 3 as P, as P is a prime number, so 3 is also prime number, we know that, and A square as suppose 9 square. We know that 9 square is divided by 3 because 9 square means 81 and 81 is always divisible by 3. So similarly, we can say that 9 is also divisible by 3, similar to that thing. If P divides A square, if 3 divides 9 square, then P divides A, that means then 3 divides 9 also. So hence the result is true. We will apply this thing in exercise 1.3. For this reason I have discussed about this. Our first question in exercise 1.3 is we have to prove that root 5 is irrational. So let us assume that root 5 is rational. So there exist two integers a and b such that root 5 can be written as root 5 equal to a by b, as any rational number is in the form of a p by q format, where a and b are coprimes. Coprime means we know that they have only common factor between a and b is only 1. So do the cross multiplication, you will get a equal to b root 5. Squaring both sides, we get a square equal to 5b square. Now we can apply this previous rule which I have written. So now can I say 5 divide a square, therefore 5 divides a square, that is 5 divide a also. So a equal to 5c for some integer c. Therefore a square equal to 25c square implies that a square means 5b square equal to 25c square. As a square equal to 5b square, we have previously proved. Now cancelling 5 from both sides, we will get 5 5 is 25, b square equal to 5c square. That is 5 divides b square, that is 5 divides b also, but it contradicts the fact that a and b are coprimes. Why? Coprime, what is the definition of coprime? They are coprime when they are said that if they have no common factor except 1. But here you can say by 5 we can divide a, and by 5 we can divide b also. So they have minimum common factor 5 except 1. So for this reason they are not coprimes. Therefore by contradiction we can say that root 5 is not rational, that means root 5 is irrational. Hence the proof follows. I think you can understand easily this proof. So next we will do question number 2. Sorry for the disturbance. So let's start. Now question number 2. We have to prove that 3 plus 2 root 5 is irrational. Like before, let us assume that 3 plus 2 root 5 is irrational. Sorry, not irrational, that means rational. So there exists two integers a and b such that the given number can be written as a by b form, where a and b are coprimes. So 3 minus a by b equal to 2 root 5. So 3b minus a equal to 2 root 5. That 3b minus a by 2b equal to root 5. So from equation 1 we get LHS of 1 is in the form of p by q, which is rational, but RHS of 1 is root 5, which is irrational. So by contradiction we can say that 3 plus 2 root 5 is irrational. Now next, to better understand, we will do another sum. 3 1 by root 2, we have to prove that it is irrational. So similarly, like before, let us assume that 1 by root 2 is rational. So there exist two integers a and b such that the given number can be written as in a by b form, where a and b are coprime. Implies that root 2 equal to b by a. From 1, LHS of 1 is root 2, which is irrational, but RHS of 1 is rational. So by contradiction we say that 1 by root 2 is not rational, or consideration is wrong, so that means it is irrational. I think you can easily understand. Next, we will go to exercise 1.4 directly, because there is generally no concept to give you. You can easily understand, like we previously have done this type of sums in 9. Exercise 1.4. At first I am to tell you, you have to prove that it is terminating or non-terminating decimal expansion. So do remember, if it is terminating, then denominator must not 3 and 7 or 11. If 3, 7 or 11 in the denominator, after factorizing this denominator, if you get, then obviously it is non-terminating repeating. But if you get after expanding it or after factorized it, the denominator, if you will get not 3, 7 and 11, then you can say it is terminating. So let's see. 13 by, let's go to graph and do the factorization. 5 6 ja 30, 1 2 5 2 ja 10, 2 5 5 5 ja 25, 5 1 2 5 ja 5 25 ja, and 5 5 ja. Here you can say only 5 to the power 5, that means only 5s are available, so it is terminating. decimal expansion. It is terminating. Next, we will do question number 7. 129 by 2 to the 2 square 5 to the power 7 into 7 to the power 5. Here you can see that 2 square 5 to the power 7 are present, but 7 to the power 5, I have told you, if 3 7 or 11 are present, then obviously it is non-terminating repeating. So it is non-terminating repeating, sorry, non-terminating repeating decimal expansion. Next, we will do question number 9. 35 by 50. If there is cancellation is possible, then do the cancellation. 5 7 is 35, 5 10 is 50, 7 by 10 equal to 10 can be written as 25. Here only 2 and 5 are available, but 3 7 or 9 on the denominator is not available, so it is also terminating. Next, we will do question number 3. 1 2 is not necessary because 2 is in the question number 2. You have to do the division of these numbers, so you can easily do the division. So question is, you have to show that it is rational number or irrational number. The given number is it rational or irrational? Here you can see it is decimal expansion. If we omit the decimal number, then we will get, after writing 1 and then some zeros, so that, and it can be written as in the p by q format. You have already done suppose 0.5, then after omitting the point we can get 10, 505, 5 to 10. It is in the p by q format. Like this you can also arrange it in the p by q format, so it is also a rational number. I think you can easily understand. So now we have to show that the key prime factors of q will be either 2 5 or others. Here after omitting the decimal expansion we will get 10, so the prime factor of q will be either 2 or 5 or both can possible, because when you will get 10, after omitting this point you will get 1 after some zeros, and if it may be possible that it is divisible by 2 or it is divisible by 5, so you can get 2 5 or even both, that means 10 also. So here's we will finish. If you liked it, share the video, and if you have any query you can comment me. That's all.